In this lesson, we're looking at hyperbolas, and hyperbolas equations look very much like the equations for ellipses. You'll notice that it's kind of fractional and set equal to 1. Big difference, minus sign as opposed to a plus sign. Also, notice that A is always the leading variable. It's not a matter of which one is bigger or not. The A is under how it opens. So the x squared being out in front, that means it's opening horizontally. Y squared out in front means it's opening vertically. A little bit more vocabulary. The transverse axis is the axis that connects the vertices. So we would say that it's the segment connecting the vertices. And the conjugate axis is perpendicular to that transverse axis. Remember that both of these axes pass through the center of the hyperbola, and so later on in the lesson, when we're finding the equation of a hyperbola, it's of note that the midpoint of the transverse axis, or the midpoint of the conjugate axis, would be the center of the hyperbola. Another kind of relationship, but not quite, between ellipses and hyperbolas is, recall that in an ellipse, this was the equation that we would use in order to solve for c, whereas c squared equals a squared plus b squared in a hyperbola. So let's get started. If I'm graphing this hyperbola, first thing I want to do is figure out where the center is. This is 0, 0. And very much like how we plotted the vertices and the covertices for an ellipse, we're going to do something like that for a hyperbola. So for this a squared value of 4, that means I'm going to go 2 spaces to the right and 2 spaces to the left. And then this b value is 1, so I'm going 1 space up and 1 space down. And rather than connect the dots as I would for an ellipse, this gives me, I can think of it as a rectangle. And if I draw, I know it's really hard to see, if I draw the line that contains the diagonals of this rectangle, what I'm drawing are the asymptotes for this hyperbola. So now that I've drawn the asymptotes for the hyperbola, once again, notice that the x variable is the one out in front, which means these 2 points are the vertices of my hyperbola. And then I can just kind of hug the asymptotes and pass through my vertex, and that's my answer. There's our graph. Part B. Again, my center is 0, 0. This time, my A and B values are kind of ugly. My A value is the square root of 5. My B value is the square root of 3. So that A value is approximately 2.2. My B value, approximately 1.7. So I'm going to make every 2 spaces represent 1, just so that this is a little bit more spaced out. Okay, and my center again is at 0, 0. Vertically, I'm going to go 2.2 spaces, so 1, 2.2, 1, 2.2. Those are my vertices. Notice how this is going to be opening vertically. And 1.7 to the right, 1.7 to the left. And if I make a rectangle out of this, the diagonals of that rectangle will be contained in the asymptotes of my hyperbola. So remember that I said because the y is out in front, those 2 points are the vertices of my hyperbola, and I'm just going to hug the asymptote. And there it is. In example 2, the instructions say graph the hyperbola. Since the equation is not in standard form, for this particular example, all I'm going to focus on is getting the equation in standard form. We do have a couple more examples back here of actually graphing it, and I provided you grids for that, so we'll do that there. So in example 2, I want to get this equation in standard form. So very much like what you did with ellipses, you want to get your x stuff together, your y stuff together, loose number on the right, it's already there, and I'm probably going to have to complete some squares here. So 25x squared plus 100x minus 16y squared plus 96y equals 444. I have to factor the 25 out of the x stuff, factor negative 16 out of the y stuff, so I'll have 25 times x squared plus 4x plus blank minus 16 times y squared minus 6y plus blank equal to 444. So let's zoom out here. We have to fill in these blanks with the value that's going to complete the squares. This is 4 because 4 divided by 4 is 2. 2 squared is 4. This number will be 9 because 6 divided by 2 is 3, and 3 squared is 9. But keep in mind, we didn't add 4 here. We added 100. And we added negative 144. So when all is said and done, I've got 25 times x plus 2 squared minus 16 times y minus 3 squared equal to 400. Last step is to divide the whole equation by 400. So I'll have x plus 2 quantity squared over 16 minus y minus 3 quantity squared over 25 equal to 1. And now this equation is in standard form. Here, a little bit more practice graphing hyperbolas. My A value is 8, my B value is 9, my center is at negative 1, comma, negative 4. So negative 1, comma, negative 4, 1, 2, 3, 4. And vertically, I'm going to go up and down 8 spaces. There's one of my vertices. There's another one. I apologize for going off the grid. From my center, I'm going to the right and left 9 spaces. So here and there. And if I make the rectangle connecting those 4 points, Here's one of the vertices of my hyperbola, and it's pretty wide. And then the same idea down here. If you'll apologize that we're kind of, if you'll forgive rather, that we're kind of drifting into the other problem, you see that it kind of does this. Okay. Part B, once again, it's not in standard form. Got to get it in standard form. 2x squared minus 12x, get my x stuff together, minus 3y squared equal to 36. I'm going to factor a 2 out of this and complete the square. Since there's no just y term, I don't need to complete the square. Some of you may feel more comfortable rewriting that y squared as y minus 0 squared so that the y coordinate of the vertex is right there staring at you. And then this equals 36 plus 18 because I added 18 to the left side of the equal sign. So I've got 2 times the quantity x minus 3 quantity squared minus 3 times the quantity y minus 0 quantity squared equal to 54. Divide the whole equation by 54, and this equation is now x minus 3 quantity squared over 27 minus y minus 0 quantity squared over 18 equal to 1. So this a value is the square root of 27, which is approximately 5.2. This b value is the square root of 18, so 4.2. My center is at 3, 0. So 3, 0, going to the left and right, 5.2 spaces to find my vertices. 1, 2, 3, 4, 5.2. 1, 2, 3, 4, 5.2. And then up and down 4.2, 1, 2, 3, 4.2, 1, 2, 3, 4.2. Make my little rectangle. In example 3, we're writing the equation for the parabola. So we know the vertices. Maybe it's a good idea for us to sketch this out. 3, 2, 3, 6. That means it's opening vertically. So I know my equation will be y first and then x. Well, what else goes in those numerators? The center. Remember that the center is going to be the midpoint of the transverse axis. So that means it's the point in the middle of the vertices, meaning it's going to have an x-coordinate of 3 and a y-coordinate halfway between 2 and 6. So that's 4. The transverse axis, notice, is 4 units long. Remember that that transverse axis, this segment here, that is twice the value of A. So this distance between the vertices is 4. 4 divided by 2 is 2. That means 2 squared is 4, the A squared value here. I'm told the conjugate axis length is 10. Remember, that's this length all the way across. Well, half of that is 5, and 5 squared gives me my b squared value, and then equals 1. So there's part A. For part B, Again, I'm given 2 points that I know the center is the midpoint of. So the center is going to be something comma negative 2. 2 plus 12 is 14. 14 divided by 2 is 7. That makes 7 the number halfway between 2 and 12. So the center is 7 comma negative 2. The foci, if I were to sketch them out, would be 2 negative 2 and 12 negative 2. That means it's opening horizontally. So it's x first this time. So x minus 7 quantity squared over, and then y plus 2 squared over equals 1. Now, for this problem, they've given us the asymptotes. So notice the significance of that. We haven't talked much of the equations of the asymptotes, but in your notes, notice the slope of them. Uh-oh, they're not the same. Or are they? Notice this is b value, I'm sorry, the y value over x value. Same thing here, y value over x value, because that's what slope is. It's rise, which is a vertical distinction, over run, which is a horizontal distinction. So my y value is 3. 3 squared is 9. My x value is 4. 4 squared is 16. And there is our equation. Very much like ellipses, hyperbolas have eccentricity. The formula is the same. What's different is how to find the value of c. So c squared equals a squared plus b squared for a hyperbola. So this is 144, making c 12. So e will be 12 over my a value, which is the square root of 64, or 8. So my eccentricity is 1.5. In part B, again, c squared equals 15 plus 75, a squared plus b squared. So that's 90. So c is the square root of 90. A is the square root of 15. So eccentricity is square root of 90 over square root of 15. And we're just going to type that into our calculator. And get 2.45 approximately. The last thing we're looking at in this chapter is classifying a conic using the discriminant. And the discriminant here is the same discriminant that you saw way back in Algebra 2. It's just a different context, but it's still b squared minus 4ac. So look at what b squared minus 4ac is in these expressions, or rather, look at where the b is, look at where the a is, look at where the c is. So the only terms we're interested in are the x squared, the y squared, and the xy term. It'll be a parabola if that value is 0. It'll be a hyperbola if the value is positive. If it's negative, you've got to look closely at a few conditions. So if it's negative and the b value is 0 and the a and c value are equal, then it's a circle. If either one of those conditions is not met, then it's an ellipse. Let's take a look at part A. It is mostly in this form. It's not in the right order, but everything's on the same side, so that's okay. So I know my a value is 3. My b value is 6, and my c value is 3. So that means b squared, which is 36, minus 4 times 3 times 3. Oh, well, that's 0. That makes it a parabola. For part B, this 3y squared is on the wrong side of the equal sign. I want it on the same side as this 2xy and 6x squared. So I'm just going to subtract it over and get 6x squared plus 2xy minus 3y squared minus 15x equals 5y plus 18. If you really, really wanted to, you could bring everything over to the left-hand side. It really doesn't make any difference. The only terms we're interested in are those three. So A, B, and C. B squared is 4 minus 4 times 6 times negative 3 means that this is a positive value, making it a hyperbola. Finally, for part C, once again, I have something in the wrong place. I want to bring this 4xy over, so I'm going to cross it out here and make it minus 4xy on the right-hand side, such that my A value will be 2, B is negative 4, and C is 8. B squared is 16 minus 4 times 2 times 8. Again, the numeric value isn't necessarily important unless it's 0. This is a negative number. Because it's a negative number, I have a couple of choices.